Today we'll see about the instantaneous center. Okay, I'll just draw one link, okay, or you can say a kinematic chain which will be having 4 links. Okay, so this is my 4-bar chain mechanism. As you can see, this is my 4-bar chain mechanism which will be having 4 links. Okay, I'll just name this link as A, or I'll write capital A, then B, this is my link B, this is my link C, and this is my link D. This is my link D. So now you can consider this is a 4-bar chain mechanism. Okay, I'll just write here. This is 4-bar chain mechanism. 4-bar chain mechanism. So for this, I will just do now this link, the D link. D link is fixed. As you see here, I'm just fixing this. Okay. So now this is yeah, this is my first link. I'll just say that this is my first link. This is my first link. This is my second link. This is my third link. And this is my fourth link. So you can see this, whatever letters I have put here, those you can put here. Okay. So I'll just draw it once again. All right. I don't know why it is not going, this one. Okay, fine, I'll draw it once again otherwise. So you can see here, this point I'll just mark it as A. Point I will mark it as B. Yeah, A. This point as B. This point as C. And this point as D. D. Okay. So now you can see here, this is my first link. This is my first link. This is my second link. This is my third link. And this is my fourth link. So you can see here my A and D link is fixed. Okay, so when we are going for the instantaneous center, you have to remember this. There are 3 types of instantaneous center. First one is fixed. You can see this is fixed instantaneous center. Second one you can say permanent instantaneous center, and the third one is neither fixed nor permanent instantaneous center. So there are 3 types of instantaneous center now. Okay, there are 3 types of instantaneous center. So now in this you can see, first we have dealing with fixed instantaneous center. Now which are fixed instantaneous center? So as you can see here, this is my A and D. This link has been fixed. So that means the point, this center you can see here, whatever this point is there, I'll just whatever this point is there, where the link AD and AB are joined, there will be one center here. This, I'll just mark this. There will be one center here, this one. This is nothing but is in my fixed instantaneous center, because this A point and D point both are fixed. So this will be also my fixed point. So it is nothing but is called as an fixed instantaneous center. Those are called as fixed instantaneous center. So I'll just write here fixed instantaneous center. I can point out here. So these things are known as an, these both points are known as an fixed instantaneous center. Fixed instantaneous center. Okay. Now you can see here the link AB and CD. As it goes up, we can see here and then once again two centers are there meeting here. This point where BC link and CD link will be meeting and AB link and BC links are meeting. Now these both point, I will just make it color change. These, there is one more point here and there is one more point here. So these both centers are known as an, these are known as a permanent instantaneous center. Why this is permanent instantaneous center? Because as these links will be moving, this center will be moving. So it is known as an permanent instantaneous center. So I'll just write it here, permanent instantaneous, permanent instantaneous center. Yes. So these are my, so this what, now there is one method to indicate the instantaneous centers. How you'll indicate this instantaneous center? Let me do it. Now if you see here, this is a fixed instantaneous center. So I will just write this center as, this point as capital I, and which points are meeting here? 1 and 2, because this is the first link and this is the second link. So I just write this suffix of this 1 and 2. Just a minute. Suffix means it should be very small. I'll write this here. 1, 2. So this is my, yes, this is perfect. You have to write like this, instantaneous center 1 and 2. So similarly here now you can see link 1 and link 4 are matching. So this point I'll be just saying as I 2, 1 and 4. So you can see the method of writing instantaneous center are like this. I14, this is my fixed. So which are my fixed centers? I14 and I12. These are my fixed instantaneous center. Then next, which are my permanent instantaneous center? You can see here. Now link 3 is here and link 2 is here. So you can see I can write this as a I, okay, I1, sorry, 2, I23. You can see here I23. This is my permanent instantaneous center, this, and this will be my I43. This will be my, yeah, this will be my I43. So you can see here this center is known as an I43. Okay, yeah. So you can see here there are already, we have found it now 4 instantaneous centers. Okay, so this is my fixed instantaneous center. Those are nothing but which are fixed here, and these are my permanent instantaneous center, which means they will be changing as per the angle changes of this link. So now here by mathematically we can represent this instantaneous center. To finding out the instantaneous center method, we have one formula that is nothing but as n, I'll just write here, capital N equal to small n bracket n minus 1 divided by 2. This is my formula to find out the instantaneous centers. How many instantaneous centers are there in this link? This is the formula to find out. Now here you can see n is nothing but as n. This is the number of instantaneous centers, and small n, you can see these are the number of links. So here if I do it, the answer what I'm getting will be equal to, now number of links are 4. You can see 1, 2, 3, 4. 4 number of links are there. So in bracket again I'll write 4 minus 1 divided by 3. Sorry, divided by 2. So this will give me 4 minus 1 is 3. So 3 into 4, 12. And 12 divided by 3, sorry, not 3, 2 it is, sorry. 12 divided by 2, it is 6. So the answer what you are getting, it will be 6. So it is nothing but as an N, you can see here. So capital N, that is number of instantaneous centers. How many numbers of instantaneous centers you got? 6 number of instantaneous center. Now as per this we have already got here, see, 4 instantaneous centers we got, that is I12, I14, I23 and I43. Okay, so now you can see here we have got only 4 instantaneous center. Now still there are 2 instantaneous center are remaining. What are those? Just you have to do, you have to, I will just draw these lines. You can see here I will just increase, oh sorry, I'll change the number. Yeah, I will just now take this point. You can see here I will just increase this line straight for the link number IN, so for the link number 4. So similarly this side also I can see I will just increase or extend this line like this. I will just increase this. So now at somewhere I will get this point. I will just mark this point now. At somewhere I will get one point here. When I extend those lines from this link passing from the link 4 and link 2, I'll be getting one line here. So you can see basically this link represents what? This link represent, you can see corresponding to those, because this is the bisector. When we draw the, it means, see here, if I take a compass from here and if I bisect this point, so somewhere this line will be cutting at the middle. So similarly here also at down, somewhere the down line it will be cutting somewhere. So if we extend this line like this, so that line will be matching here. So that is nothing but as in this is the neither fixed nor permanent instantaneous center passing from 3 and 1. So that means this is my instantaneous center which will be named as I. This is passing from 1 and 3. That means it is nothing but as an instantaneous I13. So you have to name it as this instantaneous center as I13. So this is my neither fixed nor permanent instantaneous center. So similarly, you can see here if I hold a compass here and I just bisect this at the right angle, that means one line will be passing through this, through the 2 link and the 4 link. So what I'll be doing, you can see if I keep a compass, I'll just pass. So what I'll do, I'll hold a compass here and I'll just bisect this. So that means from here one line will be passing. Okay, so that line I'll be drawing here. I will just extend this line. Okay, I will just extend this BC line. You can see BC link, that I'll be extending like this. So for extending that line, I'll be just changing my color. So you can see here, if I just go on extending this line, so you can see like this, if I go on extending, I have extended now this BC line. So similarly, this AD, where is it's fixed, So that horizontal line also I will be extending here. So you can see here I have extended this line, and at some extent this point will be meeting. Okay, so this point, whatever which point it is meeting over here, you can see a corresponding to this, which are the links 2 and 4. You can see here 2 and 4. So that is my one more instantaneous center I got. That instantaneous center is nothing but is neither fixed nor permanent instantaneous center. It is okay. So that I can write as I I 2 4. Okay, this can be written as I 2 4. So this is my last instantaneous center. So you can see this is my center. So I got now 6 instantaneous center. In this, those are 2 fixed instantaneous center. 2 fixed means already these are fixed. I14 and I12. Okay, these are 4. The numbering you can do as per your choice. Okay, it is not hard and fast that I should take this numbering. You can do from like this also. 1, 2, 3 from this side also you can start. I have started from this. Okay, anti-clockwise. You can start from clockwise. 1, 2 like this also you can do it. So here you can see the link is fixed. That means the fixed instantaneous center. Those are 2 fixed instantaneous centers. Then the second one, permanent instantaneous center, means these one, which are at the above of these links. Permanent instantaneous center are nothing but these can be moved as per the angle are moving. Okay, or the links as per the link or movement link. This permanent instantaneous center can be moved or changed. These, the remaining are neither fixed nor permanent instantaneous center. It is neither. Okay, I just made a mistake over here. So neither fixed nor permanent instantaneous center. These both you can see here. I have extended these lines from the links, respective links. You can see from the link AD, I have increased this line. From the link BC, I have just taken. So you can see the corresponding links here, 2 and 4. So this is my instantaneous center 2, 4, and these corresponding links are 1 and 3. I have just extended this line. This is my corresponding line. This is nothing but I13. So these are my neither fixed. I'll just write here. So this both okay. So here I'll just write that neither fixed nor permanent. Permanent instantaneous centers. So these both are my I13 and I24 are neither fixed nor permanent instantaneous center. These are permanent instantaneous center, and this whatever you can see the below, those are fixed instantaneous center. So as you can see how the instantaneous centers can be found out mathematically, the formula I have shown here, n is equal to n bracket of n minus 1 divided by 2. So here there are 4 links, so it is 4 minus 1 divided by 2. So that will give you number of instantaneous center as 6. Okay, so this was the first part. So how we have to make out this number of instantaneous center. So this part is finished. Now I'll just extend this part now. How to locate the instantaneous centers. You see how to locate the instantaneous centers. The location of instantaneous centers. Okay. How we can find out this. So that part I'll show you once again here. Okay, this has been done. Yeah. Now, how we have to find out the location of the instantaneous center? Means there are different types of motions, okay, and link attached with the link. So how to find out? So basically here there are some arrangements. If you can see here, I will fix this point. This is my this, yeah. Okay, you can see this is my one link. Okay, and this is my other link. And this link has been fixed. Okay, this link has been fixed. So I'll just name this as this is my first link and this is my second link. So if this kind of link is there, then definitely I will try to spin this. Okay, so then definitely my instantaneous center will be locating at the joint of this link here, at the joint of this link. So this is nothing but as my instantaneous center that I can write as here. Again I can write as I. Yeah. So this is my I12. This is my instant. So that means if two links are attached like this in this way, so then definitely this link will be definitely the instantaneous center of this link will be lying at the spin or the pivot point. Okay, so this is the first kind of arrangement. If suppose now I have a configuration like this is my link which has been fixed. Okay, I'll just fix this link. So if I fix this link and on that one disk is there which is rolling, like this one disk is there which is rolling. Okay, so this you have to assume that this disk is rolling without any slipping. So that means if it is turning like this in this direction, okay, if it's turning in this direction, okay, then if I consider one point over here, okay, if I consider one point on this, that is A, this is my point A. Okay, so if I consider this point on the disk, the velocity will be in this direction. You can see here, because it is trying to move like this. It is trying to move at the downward motion. Okay, so then the perpendicular we can see here, if we see the perpendicular will be lying here like this. Okay, so this is my A point. If I say this is my A point, and again I have a point here on this disk, like this point I have. Suppose this is my B point. Okay, so suppose this is my B point, which is lying on this, and that will what which kind of, suppose like disk is trying to move like this word in the anti-clockwise direction. So that means the velocity this, now this the point is above, so it will try to come down. This point is at below, so this will try to come up. So that means if this point is trying to come like this, so yeah, if this is the velocity of this point B point, this is the velocity of this point, suppose. Okay, then if I draw a perpendicular, it will be here. You can see it is always 90 degree. Just remember this, it is always 90. So this point is here. So you can see here, this is my now link 1. I will just name this as link 1. Okay, and this as a link 2. So now my instantaneous center will be lying at this point. This is nothing but as a path of contact, or a point of contact. You can see here, this is the point of contact. So this is nothing but this is my instantaneous center. This is my instantaneous center. Okay, so I will just say here, this is I12. Okay, Here it is I. This is my, again I want to instantaneous center 1 2 with respect to this. If I do it, it's my 1 2. Yeah, so you can see here this is my I12 which is lying on this point. So similarly, if I take C point also, somewhere it will try to come down, this arrow will come try to down, but if I draw a perpendicular it will meet here. That means if this type of configuration is there where the disk will be rolling on the one link respect to other link, that means without slipping, that means its instantaneous center will be locating at the point of contact. Here the point of contact is there, so that means here it will be the instantaneous center of this configuration. So now one more case, if I consider in this, suppose like if I directly consider one link again like this, which is fixed link. Okay, so this is my fixed link, and on this link, suppose if I place a slider, you can see this is my slider. Okay, this is sliding in which direction? This direction. Okay, I'll make the direction like this. It is sliding in this direction. So this is my, first of all, this is my first link. I'll just write this is my, and this is my second link. Okay, so this is my second link. So now this slider is trying to move in this direction. So if I consider one point on this again, if I consider one point this here, okay, so its velocity will be trying like this in this direction. When the slider is moving horizontally, the velocity will be in the horizontal direction. So the velocity of this point will be this. So I'll just write this point as A. So it will try to move like this. So if I draw a perpendicular, then it will be heading towards like this. Here. And the perpendicular will be, or this will be at the direction here. You can see. So straight. So similarly, if I take one more point on the slider, like this, if I consider one more point here, suppose. So again, this is a slider is moving in horizontal direction. If this is my second point here, B, and just write this B. So it will try to move in horizontal direction again. Okay, it will try to move in this direction. So what will be my perpendicular? If this will be the velocity direction, if I draw the perpendicular in this direction, it will be again up. So as you can see, the velocity of this A is in the horizontal direction, okay, and the velocity of this B is again in horizontal direction. So the perpendicular when I draw, then the velocity of both the points doesn't or the instantaneous center of these points doesn't matches. So that means if the sliding motion occurs between the first between the two links, okay, then always the instantaneous center will be infinity. Okay, they will not match anywhere, so it is nothing but as an infinity, because here you can see at some extent of the point they will meet, but here it doesn't meet anywhere. So that means the instantaneous center in this kind of configuration is infinity. Means a slider is moving in this direction or in this direction, it will be infinity. Suppose if my slider is moving in downward direction, okay, then the velocity will be in the downward direction. So if I draw up, so then at that time I have to draw my perpendiculars in horizontal direction. So similarly, if I make this whole configuration like this tilted, that means they will not match, they will not meet, these both line they will not meet, it is again infinity. So similarly, like suppose one more condition, if I take here, if I say this is my, this is, sorry, suppose like this is my configuration, suppose this is my configuration, okay, and now this link has been fixed, You can see here this link from inside I'll just fix. You can see here I'll just make this link as a fixed link. And again, if I keep, I'll be just keeping one slider on this. See, if you have any difficulty, you can go through it in the textbook. Also, same configuration it has been given. So I am showing the same configuration. Okay, if this is the condition. Okay, so this 1 point, if I take on this, if this is 1 point, okay, and this is my second point. So this, when this is, see this, you can see this is the curvature. You can see this is the curvature. So in this condition, my velocity will be this side. If I consider this A point, I'll just write this point as A point. So I'll just try to make it easy. See, you can see this point. This is trying to move downward. See, that means the velocity will be acting in somewhat in the downward motion, like this, here, like this. Okay, and this point you can see it is in the other side. So it is trying to come somewhat up. Okay, so for this point, the direction will be like this, suppose. Okay, so it is somewhat like this. This is my B point. Okay, so this is my B point. Yeah, this is my B point. So similarly, if I do this like this, that means now the velocity of the A will be, this is my first link. Okay, this is my first link and this is my second link. Understand? This is my second link. So if I try to make this, okay, if I extend, see this is the velocity. That means if I draw a perpendicular in this direction, if I draw a perpendicular in this direction, it will somewhat, so you can see here, it will somewhat here somewhat. Okay, and this is trying to move in this direction. So if I draw a perpendicular for this, you see perpendicular to this, so it is not so proper. So you can see the point is matching here. Okay, so the point is matching here means that means this is my, sorry, so this is my instantaneous center. In this type of configuration, when the slider is moving or any link is moving like this in this direction, that means the point of instantaneous center will be lying at the radius of curvature. Wherever the curvature will be occurring, or radius of curvature will be occurring, that point will be my instantaneous center. So in this case, we have seen like this. In the other case, last case, if I draw this diagram like this, if I draw this diagram like this, and in the same condition, if I keep a slider kind of thing here, okay, so this is my, I will just fix this point. Okay, I will just fix this point and I will just name this link. You can see here, so both the way you can do it, the convex shape and concave shape. Okay, so here this is my link 1. You can see here this is the link 1 which is fixed. Okay, and this is my link 2. I'll just name this as link 2. So on this now again I'll be taking one point. Okay, suppose like this is my A point. I will just take here that this is my A point. Okay, yeah, and this is my somewhat down. I'll just mark it. This is my B point. I will just name this point as A point. I will just name this my point A point. Okay, and this is my B point. You can see this is my B point. So this point now the motion of this will be like this. Okay, I'll see like it is moving like this, suppose. Okay, it is moving in anti-clockwise direction. So that means the velocity will be trying to move, or the velocity of the point A will be in this direction. You can see in this direction. So if I draw that velocity vector, so it will be somewhat in this direction. Okay, here you can see here. And if I drop a perpendicular here, that means if I'll be dropping a perpendicular here. You can see the velocity here. You can see, yeah, this is my perpendicular. So similarly, now this point you can see, it is trying to come inwards. The B point will be trying to come inward. So at that point, here the velocity will be like this point. So it is almost nearby. So somewhat it has been changed like this. It is not see, this is horizontal, but if it's more ahead, then it will be horizontal, but it is not horizontal yet. So it is just trying to, or I will do like this here. It is just, you can imagine I have not drawn it this curve properly. This curve was proper. So if the curve will be like this, okay, then if I, my velocity will of the B point will be in this direction like this. That means if I draw you have to draw a perpendicular 90 degree for this. So if my perpendicular goes like this, the point which will be meeting will be this point. So this point is nothing but as in my instantaneous center point. This center is nothing but an instantaneous center. Okay, so this is how we see the different configuration. You can see here in the simple link, you can see the point will be I12 this here the I12 will be locating here. I'll just mark those points. Okay, here my I12 will be here, you can see this, and here instantaneous center, that is my I12 doesn't match, so that means the I12 point is at infinity. Okay, these points are at as infinity. So here you can see, and this point, okay, from the center point is known as the radius of curvature. Okay, so here you can see, I will just mark this I, and I will just say it 1 2. So my this point is the instantaneous center lies at the radius of curvature. Here also similar thing, I'll just write I, and here 1 2. So my radius of curvature will be locating at the instantaneous center will be locating at radius of curvature. Okay, so this I'll mark these points both as this point and this point. This point are known as an radius of curvature. Radius of curvature. So you can see if the path is like this or the link is like this. Okay, you can see here both I have shown convex and concave, both I have shown here. In this situation, always the instantaneous center will be locating at radius of curvature. Okay, and in this link, the radius, your direct link at the pivot point or at the spin point, you can make out the radius of instantaneous center. So as here the disk is rolling on this, okay, then the radius of the instantaneous center will be at the point of contact. I'll just write here again if you want, then this is in this you can say point of contact. Okay, in this point of contact, and in this slider when slides on the surface or link, then it doesn't matches, it is instantaneous center will be infinity, at infinity. And in these conditions, both the conditions, the instantaneous center will be at radius of curvature. Okay, so this was about how we locate the this locations, right, locations of instantaneous centers. So this was all about the locations of instantaneous centers. Okay, so this was